got into the security industry because I believed that a lot of big things were broken, and I thought that I might have a better path forward to fixing them. So I'm just going to share 3 stories with you. That's it. The first one is about deception. The second one is about the power of being connected. And the third one is about sharing. So I gave the keynote speech in Las Vegas a few months ago, and they asked me to bring that same mask here today because I got on stage wearing a 25-pound latex mask that made me look like an 80-year-old man. And the mask was actually pulled right off a Hollywood film set. It was a mask that came from this interesting story I was reading online. There was a guy about 75, 80-year-old man who was robbing banks across Los Angeles, Southern California. They nicknamed him in the press the Geezer Bank Robber. And then 23 bank robberies later, he made a critical error. He was leaving the 24th bank, and this little packet of ink exploded. And all of a sudden, they watched this 75-year-old man run it like an 18-year-old kid out of the bank. It's the first time they realized they were being deceived. I found that mask, and I wore it on stage. They asked why I didn't wear it here today. I don't know if you've ever been through airport security in the US, but wearing a 25-pound mask that dresses you as an 80-year-old man, not a great way to end up on a do-not-fly list. So the first story I want to share with you is about being deceived. If you go back to World War II, there was one really incredible thing that happened in World War II that just started coming to light over the last few years. This is an M82 Sherman tank. Weighs just under 100 tons. And this is part of the greatest deception in military history. There we go, that's better. That's that same tank being carried across the battlefield by 4 men. So these are not supermen. This is an 88-pound inflatable tank generated by a very special type of weapon across World War II. This is an entire battalion of fake tanks, trucks, carriers. If you look in the corner, you can even see the dirt tracks that were left by artists that were drawing them in the dirt. This is the weapon the Germans were fighting. It actually turns out to be the weapon that won World War II. See, if you go back to 1944, the Germans were waiting for an attack from the British and from the Americans, and they were waiting for them to cross the channel. And the most common place people thought they were going to cross was a little place called the Port of Calais. It's the narrowest point that separates the channel. And so the Germans were amassing troops in Calais. They were waiting for the attack. There was one other place they could have attacked, and that was a little place called Normandy. But the night before the attack on Normandy, Hitler himself moved all the troops from Normandy to Calais. And the reason is because what he was hearing was coming from 1,500 soldiers that were known as a group called the Ghost Army. These guys came from American advertising agencies in New York. They were pulled off Hollywood film sets. They came from the Hollywood studio sets and face painting and public relations and advertising agencies. These guys came through, and they would actually send drunk soldiers into town to leak plans that turned out not to be real. This right here is the 5150 Signal Service Company. This is an 800-pound amplifier that sounds like 50,000 troops coming at you at full speed. It was this amplifier played at the other side of the river that caused Hitler to take all the troops that were going to Normandy and divert them to Calais. Turns out this is the amplifier that won the war. Now, there are a lot of lessons you can learn from the Ghost Army. They're an amazing group. Most of it is actually still classified by the US government, but as they've released some of it, the one thing to me that became clear is I look at the similarity between what we do in security world and antivirus with signatures and what we do in the military world. Most of the technology we do in the world of the military is built on 15th century theories. Castle and moat. Build a really big castle, keep the bad guy on the other side of the wall. So they did a study just recently. They looked at 80 new viruses. They put them across 40 antivirus companies, and they found a 5% catch rate. 95% failure rate. How many of you would trust your business to a 95% failure rate? And yet, this is the technology that underlies not just antivirus, but most of the security industry. So we started looking at the idea of using techniques like deception, the way the military did in World War II, to actually apply it. This is Malaysian walking leaf, by the way. It's for the last 80 million years, it's virtually transformed itself from fauna into flora. This is actually an animal walking by that looks like a leaf decaying. So we took a look at this technology, and we figured out that you could take signatures for known attacks and actually layer on this idea of intrusion deception to actually inject hundreds of fake pieces of code into the application so that as an attacker is traversing a site, they start touching things that aren't real. And when they touch things that aren't real, we can detect them before that attack ever begins. The moment we do that, we started realizing you can track that attacker. You can actually watch them as they move across the website. And if you do that well, you become like a DVR. You can start to profile them so you can actually record everything they do to play it back later. And finally, if you do all of that, you can respond. I'll share with you the first response we ever built. We got a call from one of the intelligence agencies in the US. And they said, we heard you guys are the cool new technology company. We want you to come to the fort and show us what you've got. And that's not really an offer, by the way, you're allowed to turn down. So we decided we were going to go to the fort and present it. And here's what we built. We wanted to show them that we could actually respond in new ways. So here's what we built. The hacker is surfing a website. They're trying to break in. They're starting to make progress. And then all of a sudden, inexplicably, the website disappears. Screen goes blank. They haven't clicked on anything. They haven't done anything. But they're staring at a white screen. And then all of a sudden, up rolls a Google map. And it's a Google map of the hacker's house with a note that says, you're definitely going to need a criminal attorney. Here are some near your house that you should probably call. It was our way of saying we know where you are, we know who you are. I'll share with you later one that we built that almost got me fired before I had actually become an employee. I'll share that later if we have time. So the way this technology works, you've got your database in the back end. In front of that, you've got your application server. And then normally you've got, at the other side, your firewall, and then afterwards your client. And so what we do is insert ourselves right in the middle. So the first thing you might do if you're a hacker is you might do what's called session hijacking. And if I'm going to hijack a session from a website, it's either going to be in the cookie or it's going to be in the URL string or both. That's where session information lives. So here you'll see generic electronics, action equals listing, ID equals 2, and debug equals false. Well, debug information is really helpful for me as a hacker. So the first thing I'm going to do is change that to debug equals true. If that doesn't work, maybe I change it to debug equals yes or on. It turns out it actually doesn't matter what I change it to, because debug equals false is not a real piece of code. It was actually artificially added by Web App Secure on the way down. It'll be stripped out on the way back. The hacker is literally touching something that doesn't exist. That's a simple example. I'll give you another one. Here at the bottom, let's say a hacker gets smart and they go out and they call the htaccess file. We'll actually block the real one, but expose this fake one. So why do that? We already know they're a bad guy. We already know we could have blocked them back there. Why do we entice them further? So what we actually do is if you understand Linux, you can probably read through this file and you see that, hey, it points to an htpassword file. So if you do directory traversal and you spend a few hours, you're going to find this file. And if you do, sure enough, you're going to get back a list of usernames and encrypted passwords. Now you're cooking with gasoline. So if you spend a little more time on it, you can actually go out and you can actually break that encryption using a desktop decryption tool like John the Ripper. And 15 or 20 hours later, now you're in. Now you can go to that recover password file and you can log in with one slightly small problem. The user and htaccess file, that's fake. The password file after that, that's fake too. All of the usernames and encrypted passwords, we made those up as well. And the thing they logged into afterwards, that thing doesn't actually exist. But we just wasted 25 hours of a hacker's time, and they just taught us a whole lot about what their skill levels are. What it allows us to do, and I'm going to share one quick story with you. You can see on the top left the number of attacks you've detected, the number of hackers. The countermeasures is how we responded. You can see what countries they come from. You can see all sorts of interesting information. But the story I want to share with you is if you look in the bottom left, you see the number of malicious incidents. This right here is showing you by day of the week. 2 days after the acquisition, I got a phone call in the middle of the night from one of my engineers who said, you got to see this. One of our secret websites, the website that we use for next-gen development, is getting slammed by hackers. We need to see what's going on. So I log into the console, I start looking at it, and I burst out laughing. If you actually change, there's a little drop down, if you change it from by day to by hour, you'd notice that at 9 a.m. Shenzhen time on the dot, the traffic starts to spike. By noon, it peaks. At 12 o'clock, they take lunch, and it drops back down. When they finish lunch, it started to peak again, and at 5 o'clock Shenzhen time, the traffic fell off. Turns out the hackers in China are very methodical, but they don't hack nights and weekends. Second story I want to share with you is about how to track somebody. By the way, this is the only, I went through 3 serial killer stories before Juniper Legal approved this speech. If you go back and you look at the history of fingerprinting, it's been around for roughly 2,500 years. It was actually used by the Chinese and all the way back to Babylonia to sign contracts. It wasn't until the late 1860s, though, that this guy actually realized it could be used to track criminals. This is Alphonse Bertillon. He's a Frenchman who created what is known as the world's first fingerprint. Here's the question. He actually realized that there was a flaw in fingerprinting, and he decided that you could actually build a method that he humbly named after himself called the Bertillon method. And that method says if you track 12 things, the diameter of your head, the length from your forearm to the tip of your finger, 12 measurements, you could get to an unbelievable 1 in 150 million uniqueness. Now keep in mind, this is 1860s. At this point, there are only 1 billion, 2 billion people in the world, and on top of that, they don't really travel that much because there aren't airplanes, right? So this is pretty damn good, 1 in 150 million. So the question I have is, how come none of you know who he is? And the answer actually lies in this picture. In the early 1900s, 1906, there was a man that came into Leavenworth Penitentiary in Kansas. And at the time, the Bertillon method was starting to travel around the world, and this guy was getting really famous. His name is Will. And Will's in Leavenworth Penitentiary for murder, and one of the clerks that's at the front looks at the picture and realizes, after looking at the Bertillon measurements, that she knows this guy, that she's seen it, and she goes and she checks the list of all the Bertillon photos, and sure enough, she finds him. And so she finds this photo. The problem is she's looking at a photo of current inmates. So she goes and grabs the inmate. She pulls him from the cell, and sitting before her are 2 Wills. If you notice, by the way, about halfway through I changed the picture. You're looking at the left at Will, at the right William. These are 2 different people wearing almost an identical outfit, and by the way, they have identical Bertillon measurements. This was the end of the Bertillon method. It's why we have fingerprinting now. The reason I share this story with you is the entire security is built on Bertillons. If you look at how the entire industry tracks attackers, the fundamental mechanism is IP address. You've got 600 million machines connected to botnets. On top of that, if I go to the country of Qatar right now in the Middle East, and I go out and I see an attacker coming in from Qatar, and I block that individual attacker, I will accidentally block the entire country. That's because all 1.8 million people, the entire country of Qatar, one IP address. Block one bad guy, block 1.79 million customers. Those are shitty odds. So, I told you I'm going to jump off. So I started looking at this problem and saying, how do you deal with this issue? How do you get past it? And the solution, we think, lies on moving behind IP reputation to start to track individual bad guys. The question is how? And so my team built the world's first super cookie back in 2009. I assembled a group of hackers, and we started working on this concept where we would actually start to inject a dozen encrypted strings onto an attacker's machine, start tracking every single thing they do. You can go to private browsing mode, we can still track you. You can change your IP address, still track you. You can actually switch browsers, and we can still track you. So we had this incredible ability. The problem is we wanted to start sharing it. We decided the power was not in the individual, is in the sharing. And so we actually figured out a mechanism that works a lot like CSI, if you've ever watched the crime show. You know that every fingerprint has loops and whirls and ridges, and any one of them are pretty useless on their own. But by the time you get to 200 in a PC, or the time you get to 12 or 13 in a physical fingerprint, you start getting precision. At a 13-point match, and you have a 1 in 65 billion odds. Otherwise, you're precise in the world today. Turns out you can do the same thing with your computer. When we start looking at things like what browser resolution, what keyboard layout, what screen, what language, what plugins, what browser version, all stuff that by themselves doesn't really matter. But by the time you get to 200, we are now successfully tracking to less than 1 in a million false positives on the individual device. Or put another way, we pierce right through the country of Qatar, and we can tell you what bad guy in Qatar is doing. And what this allows us to start doing is building a profile of every single attacker. We're actually calling them by a name. This is Jack26. This is a real hacker. You can actually see all of the bad things Jack does. And the reason we know that is because we're literally watching every movement from the moment we first fingerprint him. The last story I want to share with you is about sharing. And it actually comes from Los Angeles. So Los Angeles has not only the worst traffic imaginable, it can take you like 8 hours to get from the airport to anywhere, but it also has 1.6 million fingerprints in its database. That means, by the way, that if you were manually looking through them trying to find a serial killer, it would take you 71 years to find them. They would die of natural causes every single time before you ever tracked them down. And so in 1977, the Canadian Royal Mounted Police, and by the way, as a quick aside, I was asked to give this speech by the Financial Times, and I didn't read the email carefully, because if I had, I would have read the part where it said, Financial Times focus on Canada. I had actually already given them my speech and loaded it up when I got on stage, and I had a Mountie on each side of the stage when I was giving the speech, and the Canadian ambassador to the US in the audience. Luckily, the Canadians have a good sense of humor. Because I said, and I believe this to be true, that this is an official Mountie. So in the mid-1970s, the Royal Canadian Mounted Police figured out this system called the AFIS system. It's the Automated Fingerprint Identification System. And it basically started to solve that problem of being able to start sharing this data across the world. So now you can detect an attacker over here, and you can find them over here. And that started to really matter in the early 80s. If you've been around long enough, you'll recognize this face. This is a guy named Richard Ramirez, who is known as the Night Stalker. He killed 13 people across Los Angeles. He was attempting to kill many more. And then all of a sudden, while leaving a crime, he made a fatal flaw. He left a single fingerprint when he was adjusting the rear view mirror of the car he had stolen. That's all it took. 24 hours later, the AFIS system had identified him. 48 hours after that, his face was on the picture on the front page of every single newspaper in California. He was on every single TV station. And 24 hours after that, he was surrounded by an LA mob and nearly beaten to death before the police intervened. Classic LA. The question that I started asking when I got to Juniper is, what if we could build an AFIS system for hackers? What if we could start to connect the dots so that a hacker doesn't become a serial hacker? And so if you look at the Sony example, in 2010, Sony had a crazy situation. There was a bunch of famous attacks known as the Sony attacks. There are two things that are notable. One, the estimated total it cost Sony is $3 to $4 billion. That's amazing. It's the largest hack ever in terms of financial damage. I actually don't think that's the interesting part. The interesting part to me is on that back corner, 28 days of network outage. Sony decided the only thing they could do was just shut the whole thing down and start over. Now, big deal. A bunch of geeks couldn't access PlayStation Network, or maybe people in this room, I'm not judging. But the problem with the Sony attack is that people made the assumption that it couldn't be anybody else. But my question is, what if this was a power grid? What if it was a stock exchange and you had no access to financial information? What if it was a bank and you couldn't access your withdrawals? And before you assume that, no, your bank must be better protected, I travel around Europe a lot, and I always give speeches, and I always ask one question at the start of every speech out of curiosity. And the question is this: how would you know if you had a hacker on your website right now? And then I ask how many of you would know. I gave a speech to 250 people at The Hague a few months ago, and not a single hand went up. That's the problem. There is nothing that tells me that your bank is any less likely than Sony. It just happens your bank wasn't targeted the way Sony was targeted. And so that led me to the thing that I'm most proud of. We ended up going to this conclusion that the only way that you stop this is that you start to share it. And the only way you do that is you leverage the cloud. And so we ended up building this system called Spotlight. And the way it works is this. When an attacker comes in, we use those 200 attributes to generate a digital fingerprint of the individual attacker. We take that fingerprint, we push it up to the cloud. In 45 seconds, we compare it to every other fingerprint in the world, and then we can immediately tell them whether or not to block it. If that attacker is not an attacker, just a good guy, we let him through. But the moment that they trip the first wire, the moment that they do something wrong, we take that fingerprint, we push it up to the cloud, and in 45 seconds, we share it with every single customer around the world. This is the first time we can go from detecting an attacker anywhere in the world to blocking them globally in 45 seconds. To me, this is the future of what we need to do in security. So with that, thank you very much, and happy to answer any questions later on.